So in this section, we're going to talk about the different types of bonds that you'll see. So there are three major types of bonds. We have ionic, covalent, and metallic bonds. So bonds will form so that each atom has a stable electron configuration. Basically, it has the correct number of electrons to be happy. Okay, so if this goes off of the octet rule, so most atoms like to have 8 electrons in their outer valence shell. Okay, so they will react in such a way to get those 8 electrons. So each atom wants a full outer valence shell. And there are the two basic types. Metallic are a little bit out there, kind of strange. So mostly we're going to be focusing on the ionic bonds and covalent bonds. Okay, so with ionic bonds, they are named ionic because they actually take electrons off of one atom and put them onto the other, creating actual ions. So at least one of your atoms will have a positive charge and one will have a negative charge. Hence the ion part of it. So the electrons will be taken away from one atom, leaving that ion or that atom positively charged, and then given to the other atom, leaving that one negatively charged. Yeah, get ready for the puns. Okay, so this forms your ions, which are the charged atoms. So the positive ion is actually called a cation. And it's positive because it's lost electrons. That may not sound right, okay, but you have to remember that electrons are the negatives, okay, the negative charge. So if it loses a negative, it becomes more positive. Now, this little memory thing to help you remember that positive ions or cations actually comes from one of my students when I was a TA. So cations are positive because cats have paws. Okay? Yeah, it's bad, but they're positive. Anyway, negative ions are called anions. They have actually gained electrons. Okay, so they have gained the electrons, which each have a negative charge, so they're gaining more negatives, which mean they become negatively charged. Okay? And the way I remembered anions negative, super nerd, but to me, anion sounds like Anakin Skywalker, who can use the Force, and that turned out to be something of a negative thing. Okay, so Anakin Skywalker uses the Force, it's negative, there we go. Okay, and just remember, ionic bonds are the ones that take the electrons. They do not share them. So, ionic bond, taken, not shared. Okay? So this is showing kind of how an ionic bond works. All right? So here we have the sodium atom here and a chlorine atom over here on the right. And you'll see that one of the electrons is taken from the sodium and put on the chlorine, okay? Which means that the chlorine has an extra negative charge. It becomes negatively charged. And the sodium has lost a negative charge, meaning that it is now positively charged, okay? And then because you have opposite charges on the two atoms, okay, they actually will attract each other. So the positive and the negative attract each other, okay? Now in this example, remember your sodium is your cation because it is positive, and your chlorine is your anion because it is negative, okay? I love this little figure here. You can see that it's actually giving the other atom one of its electrons. I just think it's really cute. All right, so ionic bonds actually happen because the cation and anion are actually attracted to each other. So this is where that phrase opposites attract comes from. It's opposite charges will attract each other. Okay? So again, this is another depiction of the same thing that we just looked at. This is the formation of sodium chloride. So sodium and chlorine, and that makes table salt. So you're transferring one electron from the sodium atom onto the chlorine atom. So you can see that the sodium ion has 1 electron in its outer shell here, and its easiest way to get to 8 electrons in its outer shell is to lose this electron, the only electron in its outermost shell, because then its outermost shell is this one right here, okay, which already has 8. It's already full. So it will dump that electron off onto the chlorine atom here. Now the chlorine has 7 electrons in its outermost energy level. So it could either dump all 7 of those or just gain 1. And it's much easier to just gain 1. So it'll take just 1 electron from the sodium to complete its outer shell here. Okay, and you can see how that works down here. And then because you have the positive charge on your sodium ion and a negative charge on the chlorine ion, they will attract each other. So ionic compounds are in the form of networks, not molecules. So we talked about this a little bit in the last section. So ionic compounds form these network solids. They are not known as molecules. Okay, so for example, with NaCl, so sodium chloride, each sodium ion is next to 6 chlorine ions. Okay, so the NaCl tells us that the ratio of sodium to chlorine is 1:1. So for every sodium ion, there is 1 chlorine ion. Okay, for every chlorine, there is 1 sodium. So for example, here we have CaF2. Now this tells us that we have 1 calcium and 2 fluorines. Okay, so there is 1 calcium ion for every 2 fluorine ions. Okay, so it's a 1:2 ratio here. And that is basically showing you how that looks. Okay, so each calcium ion actually contacts 8 fluorine ions. Okay, so when ionic compounds are melted or dissolved in water, those ionic compounds can actually conduct electricity. So it's these little tiny positive and negative particles floating around in the water, because the water will actually separate the ions. Okay, it pulls the network apart. So this is looking at it here. We have a solid right here. So once it's a solid, and this is iodine and potassium, when it's a solid, it can't actually conduct electricity. Okay, it can't conduct an electric current because all of those charges are right on top of each other. There's no movement involved. Okay. But once you start to dissolve them, right, or melted at this point, they actually separate those ions just enough that there is movement allowed to take place. Okay, so the first image here in the middle is showing when it's melted. Okay, so when it's melted, it's not all that great at conducting electricity. It just has enough space that it can move things around. Now when it's dissolved in water, okay, it actually will conduct more electricity. Now, water, because it has a partial positive charge at the hydrogens and a partial negative at the oxygen, it will actually attract both the positive potassium ions and the negative iodine ions here. Okay, and then because of that attraction, it will actually pull the network apart. So you have individual ions instead of just a mass of them now. Okay. So, because you have those particles spaced out, you can actually conduct an electric current, which will flow through the material. Interesting fact, pure water on its own does not actually conduct electricity. Okay, we're always told, growing up, don't stick, a toaster or hairdryer or anything like that in water because it will conduct electricity. Okay, that is because tap water is not purely water. It's not just water. It actually has several ions, several different types of ions dissolved in it. And those ions are what actually conduct that electricity. So, weird little fun fact there. All right, so moving on to covalent bonds. So again, remember with ionic bonds, we have one atom taking at least one electron off of another atom. So it basically mugs that atom for spare electrons. In covalent bonds, two atoms will actually come together and decide to share at least one electron each. So they will share what's known as a pair of electrons. So in covalent bonds, you always have pairs. Okay, so the bond is always with 2, 4, or 6 electrons. Okay, so the pair of electrons will be shared between the two atoms of the bond, which means that those two electrons are going to be going between the two atoms. So it does kind of a figure 8 around the atoms. Okay, so you can see here you have two chlorine atoms. Each one needs one more electron to fill its outer shell. Okay, and so it shares one electron each, which means that the chlorine atom on the left gets an extra electron from the chlorine on the right, but then it also shares another electron with the chlorine on the right. Okay, so in this case, you've got the two electrons that are forming the bond, the covalent bond between these two chlorine atoms. Okay, and that creates a covalent bond. So covalent compounds can be found as solids, liquids, or gases at room temperature, where in ionic compounds you have that network. So it's pretty much every ion in the network is connected through a series with every other ion. Okay, covalent compounds are a little bit different. So you have the compound itself is a unique individual thing. Okay, and then its interactions with other compounds that are identical to it actually determines the melting and boiling point. Okay, if you have more interactions that take place between two different molecules, you're going to get a higher melting and boiling point. If the interactions between the two molecules are lesser, then they won't stick together as well. So it's more likely that you'll find that compound as a gas at room temperature. So even melted or dissolved, covalent compounds do not conduct electricity. It's because they don't have a charge on them. Okay, because that charge is what is needed to actually move the electrons along to create an electric current. Okay, so covalent compounds will not conduct electricity. It's actually one of the easiest tests you can do to determine if a new compound is covalent or ionic. Okay. All right, so this little image here, you can see the electrons are actually being shared between these two atoms. So they keep going back and forth. One does one circle around one atom and then goes and does a circle around the other atom. Now this is an example where these two electrons are perfectly shared between these two atoms. That doesn't always happen. Oftentimes you will have one of the two atoms is a little bit greedier than the other, so it will monopolize the time of one of the electrons more than the other atom can. Okay, but basically, thing to remember about ionic, one atom will take an electron. In covalent, they share two electrons. Okay, so we're going to pause here and pick up with the next video.